Okay, it's time for another King's Claim devlog. So, where did I leave off? Start a new server. Let's just reset this. I think the last thing I did was the CPU commander was enqueuing some like unreachable jobs. And we got that working, right? But, that wasn't working. So anyway, now, the workers will build the gates and they'll build the walls and this is all fine. But it gets slower and slower and slower over time. So I'll let this run for a little while and you'll notice like it's okay. But as soon as like the second wall gets out of here and the workers have to like pathfind through the gates instead of around them, it just like the game actually gets really slow. The game's supposed to run at 10 ticks per second. So, 100 milliseconds per tick. But it's doing so much pathfinding now because the pathfinding code turned out to be such a useful way to do a bunch of things, including calculating enclosed areas and actually pathfinding from point A to point B, etc., that now I'm just doing a ton of pathfinding just all the time. Well, that's a little crazy. So I'll do my normal bootstrapping prompt here where I just say, tell it to read the README, and then I'll have it work on a new task. And while that's, ramping up, now you can really see how much slower it's getting. So what I want to do is add some instrumentation and some like performance monitoring stuff so that I can hopefully keep an eye on this and give the AI a way to understand how performance is being impacted over time, and so that it can basically be aware of what's getting better and worse, etc. Now I could just use like Ruby Profiler, which is like a off-the-shelf kind of profiling thing, but what that's going to do is it's a generic profiler that works with any program, but it's not going to have any of the context of the specific game that I'm working on or why any of the particular things are the way they are. So I'm going to try to do something a little bit more customized to this. See how slow it's getting now. I think it's doing just like a crap ton of pathfinding on every single tick for every single worker when it really doesn't need to. So, okay. OpenCode has a new update, by the way, where when it asks for feedback and stuff, it has this new this new interface where it presents a number of options and stuff. So read the documentation. What is the task you would like to work on? New thing. The game is getting slow now, and I think it's because we added so much pathfinding on so many back-end ticks that it's getting crazy. Want to brainstorm some ways of profiling and instrumenting the simulation code so that we can get some hard numbers around the performance of the game, and turn profiling into something we do regularly. I was thinking, I was going to add to that, but I guess in that prompt, that sort of menu prompt thing, you can't do multi-line inputs. So, yeah. So it's thinking, what if the game's still running? Now it's really slow. We're on tick number almost 1400 here. I think the game is set to go for 2000 ticks now before it auto finishes, but wow, that's so slow, Yeah. The last task number was T022. I like how we're back to 17 just because the to-do file doesn't have a 17 in it. I feel weird about that. I'm going to change this. I'm just going to make it something crazy. 23. What are you doing? Instrument, create profiler class to track metrics, time counts, instrument, time tick. Oh, whoa. Whoa, I'd like to brainstorm together before we just go off and start building something. Yeah, I don't have to fix all my typos. I also renamed this task to T023. So let's talk performance. What do you think would be a good strategy for custom profiling in this particular program? I see it just deleted the code. I basically said, hey, you're doing the wrong thing. It's like, okay, I'll delete my code. Okay, cool. Apologies for jumping the gun. I've reset the task, removed the premature code so we can start fresh. Regarding performance profiling for the specific simulation, here are the 3 strategies we could consider. Which one resonates with you? Option A, the stopwatch manual instrumentation. We build a simple profiler class like I started and like I was already doing for you and manually wrap specific hot blocks of code. What it does, we wrap pathfinder.findPath, game.tick, etc. Every n ticks, every 100 ticks, it prints a table to standard out. Pathfinding called 450 times, average 2 milliseconds max, etc. I'd rather do median than average, but okay. Pros, concise control, easy to see exactly what we suspect is slow, 0 external dependencies. Cool. Cons, it requires changing the code, invasive. Well, yeah, it's a little bit invasive. We could probably use some, what's it called? Monkey patching or whatever to like make it a little less invasive, but we'll see. Okay. The sampler, StackProf. We use StackProf gem to sample the running process without modifying the code much. We add a command or just a timer that runs stackprof.run mode wall, like wall time interval 1000 sleep 10. Output generates a report showing which methods occupied the most CPU time. Finds bottlenecks we didn't expect. For example, wait, why is array.each taking 50% of the time? Non-invasive. I do actually like this approach because what StackProf does, if I remember, is every interval, what it does is sort of take a snapshot of what the current stack trace is. So instead of profiling every single call to every single thing, it goes to sleep, and then when it wakes up, it takes a snapshot of what in that exact moment the current stack trace is, and it takes a few of these samples, or enough of these samples, so that statistically you've got enough samples across enough kind of random places in the code or random points in time that you get something that's statistically accurate as far as like this section of the code takes 80% of the time. This code takes 5% of the time. And it's not going to be like exact. You're not going to get exactly the same numbers as if you measured every single thing. But if you take enough samples, it's going to be so close to the real thing that it's going to be A, good enough, and B, like this says, way less invasive and way more performant. Right? So if you measured every single thing, you would start to see that your profiling code itself would take up a bunch of CPU time on its own, and it would bog the game down. But if you use statistical sampling, you basically get results that are roughly equivalent in quality. For our purposes, absolutely every bit as good, but way less of a pain. The health monitor, tick budgeting. Okay. We focus purely on the frame budget. We have 100 milliseconds per tick for 10 frames per second. What it does, we only measure the total time of game.tick if a tick takes greater than 50 milliseconds. we log a warning with a breakdown of just that tick. Output warning, slow tick 75 milliseconds, pathfinding 60, physics. Okay, that's interesting. So I kind of like a little bit of a mix, maybe. Maybe I want kind of a blend of B and C, and why is because I would like it broken down into the actual game's core logic, like pathfinding, physics, etc. But I want the statistical sampling as well because it's just a better technique overall, I think. Pros: quiet when things are good, screams when things are bad, great for production. Yes. However, the sampler doesn't have that much overhead, so you can run it in production all the time. And I want to not just know when things are bad, but also the median and the typical case. Because when doing performance, there's kind of two things you want to do to really increase performance significantly, and one is get your runtime for a particular iteration down to like a nice tight range, so that like the slowest it ever is and the fastest it ever is actually a pretty narrow range. And then so that means optimizing any bit of code kind of holistically and just say like we want a nice tight consistent loop iteration time here, and then you can. And consistency is one key, so that you don't have these weird outlier situations where most of the time the ticks are fine, but then once in a while you just get a tick that's like so big and out of the ordinary that it's kind of crazy. And that would be, if you had that situation, in a lot of games you see this as like frame blips, where like you'll have really smooth frame rates, and then every once in a while the game will just glitch and it drop a bunch of frames. You'll be like, what the heck happened there? That's what you get when you have like inconsistent, spiky kind of performance. If you can get your algorithm down to where it's incredibly tight, incredibly consistent, you're going to have a much smoother, more consistent experience. And because this game's going to be played online and over the network, and the network is going to add its own jitter and its own unpredictability, it's going to be important to try to get at least the back end consistent. That will eliminate a lot of variables in terms of user experience, that kind of thing. And then the second thing is, once you've got that consistency, then you can then look to optimize the code and take things out. So to make to keep the super consistent tick time per frame, but then shrink that time per frame so that it just gets more efficient. So the first thing is partly a user experience thing. You just want consistency. You want your game to feel very reliable, smooth, etc. And the second thing is an efficiency thing, where if I can then shrink the size of a particular tick while keeping that nice tight consistency, I can run more game backend server instances per CPU, per whatever. And so I can run a lot more games with the same hardware. If that makes sense. All right. Pros: quiet when things are good, screams when loud. Okay. Cons: might miss death by 1,000 cuts, where everything is just slightly slow. Yeah. This is more the problem with this approach, is that the sampling one will catch this. Like if 99% of your ticks are like just below the threshold, they're like consistently 48 milliseconds or something, or sorry, like 99 milliseconds or something. Like they're hitting the 10 frames per second threshold, but like just barely. You won't know that with the like just tell me about the bad stuff approach. So I think I want statistical sampling, but I want it expressed in the game's terms. So, given your concern about pathfinding, specifically option A seems like it would give you the hard numbers. We're calling pathfinding our times, blah, 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 blah. Okay. Interesting breakdown. I actually think I want a blend of option B and option C, but I'll explain why, and you can tell me if you think I'm missing something. The stack prof idea is great because I think that statistical sampling, as a general rule, is a great way to see holistic performance with very little overhead, which means we can run the profiling in production, not just development environments. The part from option C that I really like is then expressing those stack traces, statistical sampling in King's claim specific terms, such as grouping performance by buckets, like pathfinding and physics, etc. Can you, well, first of all, what do you think of that idea? And second of all, what would a blended approach look like? So we'll let it think. Go back to the browser for a second. Yeah, game's over. Did finish just fine. So everything's still working. The only uncommitted code I have is the new task, which is fine. So let's see what it comes up with. Finalizing recommendation. That sounds like a very sophisticated and scalable approach. Oh, thanks. It's essentially namespace-aware sampling. Okay, we'll give it a name, sure. You get the low overhead of statistical sampling, no time.now calls wrapping every method. Yeah, good. But you process the raw dump to give you the high-level semantic meaning of pathfinding versus physics that you'd normally get from manual instrumentation. Ah, yes, see, I like that. The blended strategy. Here's what that looks like concretely. The collector, StackProf, we integrate StackProf, we run it in CPU mode, so we ignore the sleep time between ticks and focus only on the work. We don't touch the Pathfinder code at all. Okay. The aggregator, the King's Claim lens, we write a profile analyzer class instead of standard top 5 methods list. It ingests the stack dump and buckets methods based on their module class. Brilliant. Oh, I love this idea. Pathfinding bucket. So anything that matches pathfinding, node, etc. Great. Game logic bucket, anything that's the top level game, worker, or job queue. Okay. Infrastructure bucket, anything server, JSON, event machine. So anything network related or composing, parsing, sending network messages, etc. The trigger, since you want to do this regularly, we can set up, I don't know why that's in air quotes, set up a sampling window. For example, every 1,000 ticks, approximately 2 minutes, server automatically runs the profiler for 100 ticks, then prints the bucket report to the logs. This gives you a heartbeat of performance health without flooding the logs or killing the CPU. Okay. Propose plan of attack. Add StackProf to the project. Create a profile analyzer. The class takes a StackProf result and hashes it into our custom buckets. Integrate into server.rb and a periodic timer every 5 minutes that starts the collector, waits X seconds, stops the collector, feeds the result to the analyzer, logs the bucket repository. I'm liking this. Tell me more about the sampling window. For example, do we need to wait until after the first 1,000 ticks? What's the advantage there versus running it all the time? Maybe because we want, well, I don't want to bias the result. I was going to suggest maybe because we want the code to warm up and YJIT, the JIT compiler to optimize things or whatever. I'm just going to ask the open-ended question. Yeah. Well, I think I'll just start with that question. I had some other things bubbling in my head, but no clear thoughts or questions, really. I think the problem with the concrete whatever thing I was building first, option A, the biggest problem with it is that it's conceptually the simplest, but it's also the least powerful. And it's not really going to give you what you want, and you're going to have to manually add instrumentation in a whole bunch of places. And yeah, I'd really just rather take the stack profiler thing. It's a great question. There are two main reasons to consider the windowed approach versus always on: the signal to noise ratio, the warm up factor. Okay, I thought this might be a thing, but I didn't want to say it, because if you suggest something in a prompt, like, the AI is going to pick up on it and assume that you want your answer kind of biased toward that thing. And so I try to keep my questions very open-ended rather than prescriptive. That's just a side note of working with AI agents. If we start profiling immediately at boot, tick 0, what we see: loading times, initializing the map, creating 100 arrays, WebSocket handshakes, blah, blah, blah. What we care about. This is why is tick 500 taking 80 milliseconds? By waiting, for example, starting at tick 100, we skip the initialization phase and only measure the steady state game loop. This ensures your data isn't skewed by startup tasks that only happen once. Brilliant. I like that. Because it's the steady state game loop, like once the game's actually running, that I care about. The other stuff, initialization, shutdown, writing the results of the game server, stuff like that, that can be not terribly performant, and it's probably okay, because it's probably going to be, first of all, they're one-time things at either the beginning or end of the game, and they're probably going to be pretty freaking quick. Other than the initialization. The initialization is maybe a little bit slower, but I've got some ideas to optimize that too. But yeah, I like this. I don't think I want to wait till tick 1000, so I think even like tick 50 would probably be good. Start it relatively early, or maybe even tick 25. I don't know how aggressive I want to get, but I agree that starting at tick 0 probably not good. But yeah, honestly, probably like tick 25 or so would be a good place to start. Resolution versus overhead. Always on. To keep overhead low, under 1 to 2%, we have to sample very infrequently, every 100 milliseconds, for example. This gives a vague trend, but might miss fast function calls. Windowed. If we only run it for 10 seconds every 2 minutes, we can sample aggressively. For example, every 1 millisecond or every 5 milliseconds during that window. Okay. High frequency sampling during a window gives us much deeper stack traces to pinpoint exactly which part of the pathfinding is slow. Is it the get neighbors call or the Manhattan distance, etc.? My recommendation, since you mentioned the game gets slow, implying it degrades over time under load. Well, yeah, pretty much. I recommend the periodic high fidelity approach. So skip the first 100 ticks, run for 200 ticks, sleep for 1,000 ticks, repeat. This gives you a regular medical scan. Interesting idea. The server without wearing it down. Does that sound like a solid plan? Yes, great plan. I want to tweak a few of those variables. However, let's start sampling at tick 50, then sample for 100 ticks. I keep typing tickets. Then wait until tick 150, sample for another 100 ticks, etc. in a loop until we're done. As far as the sampling window size, we're trying to hit a target 100 milliseconds per tick. So I wonder about sampling every 100 milliseconds or any multiple thereof, because I worry that this might create a bias in the sampling data, whereby our samples inadvertently align with the ticks in a way that I don't even know how to describe this. I'll just say throws off the measurements, if that makes sense. What do you think? Take us out of build mode because I don't want it to start writing code again. It may or may not, because even though I'm in plan mode here, you can see that I didn't switch it before it started thinking, so it's going to finish this loop of thinking or whatever in build mode. So it might start coding. We'll see. Yep. All right, it's coming together with a plan. Yes, it's already... Okay. I think we're on the same page, but before you start making changes, write your detailed plan in to-do. Oops, no. In to-do under T023. Okay. Always get the AI to write out its actual plan, so that you can review it to make sure that it really aligns with what you want and not just some hypothetical thing, See, it's starting to code again. Because I can see it started to create the folder and stuff. I should have added to my prompt right at the end, write your detailed plan under this, and then I will review it before we start. If I had said that, it would have stopped probably here. So let's look at this. Let's read the plan. Create a profile analyzer class, implement namespace aware bucketing. Okay, good. Generate summary reports from StackProf dumps, integrate profiling into game server, add StackProf dependency, done. Implement sampling lifecycle, warm up first 50 ticks, sample for 100 ticks, wait configurable amount of ticks before next sample, configure sampling interval to avoid 100 millisecond tick aliasing, i.e. 11 milliseconds, that'd be fine, yeah. Log bucket report at the end of each sample window. Okay, great. Great plan. Proceed. And meanwhile, it just added StackProf, right? Yeah, and then the plan. Okay. I started typing the ticket number of a work thing. Working on profiling. Let's see, statistical profiling approach with T0213, whatever. Okay. The branch name is still, I think, actually, is it get branch? MT023 profiling. Yeah, I just wanted to rename the branch so it matched the task number. Let's check it on the AI how it's doing. But we have a plan. It wrote it out, so I feel like I actually understand well enough what it's going to do. I don't know why it's adding all this stuff. That's weird. Is it... Why is it making these changes? These seem like nothing changes. Stack profiling. Okay. These are fine. But then it's like deleting a blank line and adding it back. That's kind of weird. I don't know what's up with that. Manage profiling, blah, 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 blah. Okay, what has it got here? Manage profiling. Warm up, active, cool down. Okay, so it's breaking it up into kind of a state machine-ish kind of thing. Log message sent. Interesting. Okay. Start profiling. Stop profiling. Yeah. Process results in separate thread to avoid blocking the game loop. Smart if that actually works. I guess if you're using event machine defer, it probably will. It's not using Ruby threads. It could send, the analysis off to a totally separate process. Like it could spawn a separate process if it wanted, but it's fine that it doesn't do that, I think. Okay, so... Oh, it's adding the timestamp because that's going to be part of the profiling. Okay. It's going to measure wall clock time. I don't know why I deleted that. Oh, probably because this was some temporary code it added. Log message received, log message sent. Was that something it had temporarily added first? And then it decided it was done with that temporary code and took it back out? No idea. No? Yes? No? I don't even know. Okay. I've implemented the blended profiling strategy we discussed. Dependencies. Add stack prof to the gem file. Created app server profiling profile analyzer. This class takes the raw stack dumps and organizes them into high-level buckets. Pathfinding, game logic, infra, and standard lib. Oh, this is a good bucket we didn't even discuss, but this is going to take care of things that like these 3 buckets do, but just doing normal Ruby things like array manipulations, hash calls, etc., or whatever. So that's good. Server integration, a modified game server to run the profiling loop, skips the first 50 ticks to avoid initialization noise, samples first 100 ticks, samples for 100 ticks, 10 seconds at a high frequency and at 11 millisecond interval, approximately 90 hertz, to avoid aliasing with the 100 millisecond game tick. Sleeps for 1,000 ticks before the next sample. See, this is not what I asked it to do. Pour at the end of every active window. It got pretty close. I mean, it doesn't need to sleep for 1,000 ticks. I think that's a lot. Because right now the game only runs for 2,000 ticks and it's already really slow. So it'll output a performance report about every 2 minutes. You can monitor the logs to get the hard numbers you were looking for regarding the cost. Okay. Okay, and where are those log files going to? I switched back to plan mode because I want to ask a few questions without it being able to, actually make any changes. For these smaller questions, this is where using a smaller model like whatever it's called, Claude Haiku or something, probably would be fine. But I just kind of stay in Gemini 3 Pro out of habit, because then I don't have to remember to switch back and forth all the time. Locating the spawner, investigating server output. Okay. If you ever played the old SimCity, was it SimCity? Where like you'd create a thing, you'd start a new game, and it'd say like reticulating splines and like doing all these kind of loading things. That's kind of what this makes me think of. Okay. Logs are being redirected to specific files under log game servers directory based on the code. Each server instance writes its output to a file named server port log. Yeah, this is where you'll find the stack file. Oh. Okay. Let me commit this code. Did it commit for me? Oh, I really don't like when it does that. I wish it would let me do it, but that's okay. It's okay in this case, but I kind of wish it would not do that preemptively. Can we split up the game logs, which are really for networking, I think? Well, no, that's not... you know what? Let's run it and just watch it. Before I judge what it did, let's just try it because it might be fine. Let's try starting a game. See what happens. Okay, we're going to take this off. It's going to start at tick 50, which is now. I didn't notice any obvious slowness. It's going to run for 100 ticks, so when this gets to message ID 150 or so, profiling should stop. So I'm going to keep my eye on here and see if it seems to get any faster. Not really. Seems fine. So I'm going to let this run for a while, and we're going to wait until it gets obviously slower to my eyes, and then I'll go looking for those performance things in the logs. While I'm waiting on that, I will ask the AI something else, though. Cool. So what specifically could I grep for to find the performance portion of the logs? Because I want to know, I want to make it easy to get at these performance numbers. And I'm hoping, like if I open a current game log, log, game servers, and we just pick any one, it doesn't even matter. Right, this is kind of what it looks like, right? You've got a timestamp, a game focused event like game init, server listening, and then if I go into here and try to find a larger one like this one, you'll see, wait, what? Oh, bytes, not kilobytes. Okay, I want a big one. You can see it logs sending messages out to players and getting messages back. Of course, right now, this is all CPU players, so it's a one-way communication. Stuff only goes out. It's interesting that it truncates that message. I guess that's fine because I don't probably need the full message, but might be nice to have that at some point. Anyway, okay, the game's obviously getting slower now. I think it said it was going to wait 1,000 ticks, so it might not start again until 10,050 ticks or 1150. I don't know which. But, yeah. Pretty soon we will be able to check out what's going on, I think. Let's go back to the agent and see what it says. The logs are written to this, blah, blah, blah. To find the performance, you can grep for the header of the report. Run this command to see all reports across all logs. Grep, blah, 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 game simulation profile report. If you want to see the specific broken down for Pathfinder, you can grep for the bucket name. Oh, cool. Okay. It's a cool way to do it. Let's take a look at the actual format here. I might clean this stuff up. I might convert it to like a JSON format and then apply some additional tooling on top of it or something like that. But let's just see what it does for now rather than prejudge it. Let's just see what we actually have. So I think that's fine. If I want to see everything it claims that I can just run this. So let's try it. Let's go to the main project folder and try this. Yeah, well, okay, I mean, that works, but I can't actually see the information. So, fun. Let's do grep -A10, which is it'll match on this pattern, but then it will print 10 lines after, that's the A, after the... It'll print the match plus 10 lines for after every match, right? So there we go. Total sample is 240, interval 11,000 microseconds. Okay. I thought we were going to do milliseconds, but... Oh, no, that is... Okay, 11,000 microseconds is 11 milliseconds. Silly Jeff. Okay, so you can see that the performance log is actually quite a bit bigger. So I don't just need 10, I need, I don't know, 50 after. Okay, that's a little big. Maybe just say, let's try 25. 25. It's not quite big enough, so let's do 30, 35. If I wanted to be efficient, I'd do more of a binary search, but here we go. So here's our example. Enumerable find, that's a lot. 20% just in that. Set include, sweeping, garbage collection. Okay. Yeah. I'm not surprised to see that the pathfinding bucket takes up 28% of the time. That's makes sense to me. It's getting real slow now, and it might have more data if I do this again. So sweeping, garbage collection. Oh, this is just other stuff that it's doing. Okay. Okay. Run machine, event machine stuff. Okay, so first of all, good to see that like network related stuff like sending messages, parsing JSON, etc. has very little, and serializing the game state and all that, very little to do with anything. As suspected, it's the pathfinding, which we added a lot of recently, that's really eating into this. I see that it's truncating the width of this, which is interesting. I think we should make this a little bigger just so we have the, well, I don't know. Maybe the AI, that's probably enough for it to figure it out, but okay. So this is pretty cool, actually. Okay. I like what it's doing on the whole. Let's commit the code we have, if any. Okay. This is excellent for a first pass. I'm kind of shocked how good this is. I'd like to make a change, however, instead of a big multi-line performance report, which admittedly is easy to read, I'd like the performance report to serialize to JSON so that every performance report is a single line in the log, and we need to ensure that the log line is not truncated so we can see the entire performance report. Then with these JSON encoded dense performance reports, I can easily build more tooling on top of this to give me a, well, I'll just say on top of this. Yeah, we're just going to go with that. Okay, so basically I'm going to ask it to convert this kind of performance report into, just create, convert it into JSON, do total samples as a key, do the interval as a key, and then the value here, and then do like a buckets key, and then every bucket has a name, and then every, just a nested object of performance, basically. We'll see where it gets. Shouldn't be that crazy. I mean, we've got a working performance report that I'm really happy with as a starting place. So just need to convert that into a more machine processable format, and then we can add tooling on top of it. Okay, here's the plan. I will modify the profiling system output as single line JSON logs instead of multi-line text tables to make it much easier for you to parse and analyze the performance data programmatically. Yeah, that's what I want. Modify the profile analyzer. Add required JSON. You know what? JSON. Do I have the OJ gem in here? I don't. We should use OJ. It's a faster JSON reader and writer. Add a generate JSON report method that structures the analysis data, buckets, sample counts, percentages, list of methods into a clean hash and returns it as a JSON string. We'll include all sampled methods in the JSON output, not just the top 3, to give your tooling complete visibility. Ooh, I like that. Because the tooling could always filter it down to just the top 3 if you want. Modify game server update, stop profiling to generate JSON report, use log event, blah, 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 blah. Okay, this sounds great. Add one more thing to this, which is I want you to use the OJ gem rather than a JSON, because it should be much faster. And I think we'll want to use OJ for message serialization in the future anyway. As you can see from the performance report, JSON serialization right now is already a small fraction of the total time anyway, so it's not really a big deal. But the OJ gem is well supported, and it's basically a JSON parser and generator that is written in C, but has Ruby bindings and is just going to make my life simpler in a lot of ways. Oh, while you're at it, I realize I never cleaned this up. So like all these comments have a ton of just like random crap in here from when I generated the Rails project, and I never cleaned it up. So I'm going to also add that to the task list. While you're at it, the gem file could use some cleanup. Remove all comments, remove all the extra blank lines except blank lines between logical blocks of gems. Alphabetize the list. Yeah, we're going to do that. All right. While it's doing that, let me read this. Added the OJ gem. Added JSON serialization. Logs the output. Now you can parse these reports programmatically, for example, to extract just the JSON reports. Great. So it gave me another grep command I could run just to get this. So cool. We're going to try that. I don't think do I need this sed command? I probably just need the grep at the beginning, but okay. So it's, look at that. Oh, it's so much better. So much cleaner. So much simpler. Yeah. Okay. Do we have tests? Let's run the tests. We haven't done that in a while. Sorry for the coughing. I don't know if you can hear that or not, but I don't even know if I wrote test suites for this. I can't remember. I guess I did, but it has almost nothing in it. I don't know. I probably didn't really ask it to write tests very often, which is fine. Oh, and it automatically committed. So let me take a look at what it did. All right, so added the OJ gem file, blah, 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 checked a bunch of stuff off, changed the way that it does the serialization. Okay. Yeah, nothing surprising there. And then gem file cleaned up all this crap. And I guess that's kind of it. So, okay, cool. Sweet. Did we do anything with the tests? Oh, see, I knew I had more tests. Running all 11 tests. There's not a lot of tests, but yeah, it's fine. Okay, so it had to fix a thing. Okay, cool. I thought I had more than one test, so yeah, I guess I do. Oh yeah, so you got all these other test files as well. Mm-hmm. Yeah, so we made a few changes recently, nothing crazy, so I think it's going to be able to figure out how to probably modify the test. Like the game code itself seems basically right. I think it's probably the tests that are out of sync with that. So we'll see what it does. Yep, that's that error. Okay. Nope. Still just that thing. Okay. All right. So it's working there. And I should probably tell it to update whatever the test harness is, like Rails test or whatever, so that it runs, so that it will run all the tests every time you just do a Rails test. Like here, if I do Rails test, bundle exec Rails test, see it only runs one thing, but there's way more tests than that. Yeah. Update the code that runs when you do bundle exec Rails test so that all tests that exist, even for the server backend, are all run at that time, rather than just the Rails focused tests. Okay, so did its commits. Yeah. I wish it would reopen on the same screen that it opened on before. But, oh, it added Mocha. Really? Gross. Why did you do that? All right. Didn't really do much. Didn't change much. Let's go ahead and push that. By the way, why did you add the Mocha gem? Let's rename this session while we're at it. Performance, profiling. Okay, I'm gonna stop it. Whoa. Did I crash it? Okay, that was weird. I had the Mocha gem because test server cleanup explicitly requires Mocha minute test to mock method calls. Oh, is that what Mocha does? Ruby Mocha gem. Mocking and stubbing library for Ruby. Oh, okay. That's probably fine. But deliberately not yet faking or spying. Unified simple and readable syntax for both full and partial mocking. Okay. Yeah, I guess that's fine, actually. I don't know what happened there. I stopped it. Maybe at a bad spot, I guess. Gotcha. Adding Mocha makes sense. Then please proceed with the rest of the work you were already doing. Okay, I completely forgot what Mocha even did, so that was part of it, I think. So what did it do? Whoa. What? Why did it delete those? Is it moving it? Oh, I think it just moved everything. So if I add everything, yeah. It didn't really delete it. What it did is it moved everything to be under the test folder or something, which is fine. Yeah, that's fine. Well, wait though. Test server, test reliability through test server reachability. Oh, it also, okay, it really just renamed the files is what it looks like. That's fine, I guess. Refactoring some tests. Let's see. It should get to the end of this task relatively quickly, I think. Hey, look at that. Okay, so I renamed all the backend test files to match the Rails naming conventions. Oh, with test at the end rather than the front. Okay. Now when you run bin Rails test, it automatically picks up and executes all 25 tests, 24 backend logic tests plus 1 controller test. Okay. That's why it had to do the renaming. I totally didn't catch that. So it basically changed the file names so that they used to start with test underscore. Now they end with test underscore. So doing that causes the existing Rails thing. I think I can just do RT. I think that's alias to Rails test, to pick up all the tests. So that's good. All right, great. Awesome. Great job on this session. Please update, I think README. Yeah. Please update README and any child docs to reflect new things you learned or built in this coding session. I love to have the AI write the documentation and maintain the documentation and read the documentation regularly. Really, the documentation in, I guess you'd call this vibe coding. I mean, like, I have actual programming experience, but having the AI write its own docs for its own benefit means I get to interact primarily with the AI and not have to worry about writing docs, even though the docs are there. All right, let's restart the Rails server and see what we got. So we'll go back. And we're going to start a new game. It's going to spawn a new thing, maybe, or it's going to crash now. Okay, we're good. Cool. Did I save the grep thing that it? Nah, yeah. I need to ask the AI, what do I grep for? Remind me, what do I grep for to get the new JSON formatted performance log lines? Yeah, so hopefully we'll get that, and we should have a performance report now, at least one. Let's try this simple one here. Oh, that's what the set is for. Okay, so this is the grep just to find the log lines, but then if I want just the JSON portion of it so that I could then feed that into like the JQ command line tool or something like that, that would work. So let's run this. Yep, there you go. And then if I do this, that will give me, that will get rid of everything up to here. Gosh, sorry for the burping. I think I have JQ installed. Okay, so then if I pipe this into JQ, now we're going to get a nice, pretty printed thing. So we can see we have really nice, compact, simple, one line per performance report, but we can print it out and read it here. So here's the timestamp of the report, total samples, interval, micros in microseconds. Yeah, cool. Okay, so now that we've got this, right, I'm probably going to stop the video here because I just have some other things I need to do today. But by doing this, right, like now I can feed this information back into the AI agents and say, hey, let's talk about what we might be able to do to make the game more performant without changing its behavior, right? And that can be really, really powerful. So, yeah. You know what I don't see in the performance report is like the ticks. Like, is the game tick? Yeah. See, there's no information here, I don't think, about how far into the game this performance report is. And that's important because the game gets slower and slower as we go on. This works incredibly well. Let's put those grep / sed commands into a simple script in the bin directory so that we can run it on demand. At the end of, or I should say after the sed command, I want you to pipe the result into JQ for nice formatting. Have any uncommitted changes? No. All right. So that's going to it's just going to write a quick script that is basically this. Yeah, which is fine. I could just write that script myself. It'd probably take about the same amount of time because this is going to take 20 seconds or whatever. Oh, no, it's even faster. All right, so okay, if I can freaking type, geez. Bin, what's it called? Show profiles. Bingo. Nice. So let's see what's in this actually. Okay. Check if JQ's installed. That's kind of overkill, but okay. Helpful if I ever move to a new machine and I haven't installed it, I guess. Oh, it even tells you how to install it. Okay, cool. Check to make sure we're in a place where we can read from the expected log directory, and then do the grep thing, and then format it. Yeah, okay, cool. Okay, this is actually better than what I would have written. I probably would have just literally copied that into a script and just been like, this will be good enough, but what ifs? Did it make it runnable too? Ah, very nice. Made it executable. Very nice. Profiling. No. Performance. Log printer script thing. Cool. All right. The whole session, we only got up to 14% on the context window. So nice. So, like I said, I'm going to stop here. Next time I come here, though, now that I've built this performance profiling, I've got the blended approach of statistical sampling plus bucketing things into logical groups, etc. Oh, no, wait. There was one more thing. Anyway, I guess I'm not going to stop the video here. But next video, I'm going to focus on working with the AI to try to actually have it suggest performance improvements. But before I do that, one last thing that should be added. Added to the performance reporting is the range of ticks that the performance report ran over for example, if a given performance log line ran from tick 50 to tick 150, we should capture that in the performance logs. This will be very helpful because performance seems to degrade degrade more and more the longer the game goes on. So this extra bit of context might be helpful. So let's get it to do that. I'll verify it by running this little show profiles script I got now, and we should be good. In fact, I'll clean out the server logs too, since I don't need the old ones now. We've got much better logs and all that. So let's do remove log server, game server logs. 29 files, yep. Delete them, logs, game servers. Cool. So I really just want new logs that have the formats I need and all that stuff. Tick range, cool. Tick start and tick end. Okay. So these are going to be the keys, I assume, that are in the JSON, tick start and tick end. So I'll run a game and I'll grep for keys that start with tick underscore, and that'll probably be fine. Okay, it thinks it's done. So we're going to run one more game here. Okay. There we go. And I'm going to do bin show profiles. Yeah, in fact, let's do a watch dash. No. Let's just do this once. Show profiles, grep for tick underscore. There you go. So we know they're getting logged now, so that's great. So our first one, 50 to 150, is good. I really want it to not sleep for 1,000 ticks. Are we sleeping for 1,000 ticks between profiling? I really think we should only sleep for 100 ticks. Wow, if I could stop typing tickets when I think ticks. We update that interval. Let's see if there's anything to commit. No, just stuff that it committed. And let me just see if I can fix this. I will say Gemini 3 Pro seems pretty powerful. I've had a lot of good luck with it, but I've also had pretty good luck with much smaller context window models. And those smaller context window ones seem to be a little faster, honestly. Yeah, okay. So profiling cooldown, yeah. I want that to be 100. That's good. I like that. Good. Which means I'm going to have to do this again. Is this thing done? No, but who cares? Let's just kill it because I'm going to start one more time and make sure that it does the right thing here. Yep. And okay. Start another new game. Maybe this will be the last one. Hopefully. Okay. Cool. Now let's, we don't have any uncommitted changes, right? But we do have things that aren't pushed. And now I'm going to do this. Is it not there yet? Oh, it hadn't finished there. Okay, so it had started profiling but hadn't finished yet. So if I keep running this when it hits 250, I should have another report, I think. 250 or 300, depending on how the math works out. I can't remember. Yeah. It's going to sleep for 100, so it'll probably start at 250 and run until 300. Now I should have another report. Maybe? Woof. Why didn't that work? Oh, because it runs for 100 ticks, so it should go from 300 to 400? I don't know. Yeah, there you go. 250 to 350. Okay. We're good. We're good. We're good. We're good. We're good. This is fantastic. Now let's just run the whole thing and just see what's up. Awesome. I love this. This is great machine readable stuff that I think is going to be critical to doing this kind of thing. I wonder, I probably shouldn't do this right now, but I wonder if I could extract this into some kind of gem that I could reuse on other projects. Maybe not, because the bucketing thing is specific to the game. No other program is going to have the same buckets as this one. I don't know. Maybe that's useful. Maybe it's not. But whatever. Problem for another day. Thanks for watching. Catch you on the next one.